Number of papers was much larger than what I expected. It was way beyond 100 papers. And Plasmonics plays a very, very large role in that. There has been a shift from themes like quantum dots and things to plasmonics, to metallic structures. That is actually a major surprise throughout the last years. In optics, metals appear to be very dull and uninteresting structures, but now they play a very important role in plasmonics as well as in metamaterials. Because plasmonics allows us to bring light from free space to the nanometer scale. I mean, for many years we believed that the wavelength of light is kind of a constant, but with plasmonic structures, in particular with their dispersion relation, we can convert the vacuum wavelength, which is typically a couple of 100 nanometers or even more than a micron, down to a couple of 10 nanometers, and that makes a big difference. Very interesting papers on energy conversion, solar energy conversion, where it becomes clear that one photon can generate not only one electron hole pair in a quantum dot, but multiple electron hole pairs, which means you can get more current, you can potentially get more energy out of quantum dots. And there are some very early papers in this direction, and the challenges are to get the charges out of the quantum dots. We've seen a few but very exciting papers on these issues. But again, plasmonics is really overwhelming. I think out of the 10 sessions that we have scheduled, there are 7 or 8 that are directly plasmonics. People dream that plasmonics might allow us to use electronic chips that we have today that have lots of metallic lines on it to not only transport electric currents but also light or plasmonic excitations. And that might be very, very interesting. Another topic that my subcommittee is concerned with are microcavities. And that they have been around for a few years, but they're steadily improving and now getting to tremendous quality factors, which means you can store the light in these cavities now up to 2 nanoseconds. That was thought to be impossible previously, but by carefully engineering, they have been improved a lot. And that's interesting for a number of purposes. You can take advantage of the local field enhancement, you can couple to quantum dots and maybe realize some of these quantum information processing ideas that are more into other subcommittees, but nano-optics has formed the basis for that.